Are you ready, Bob?
I'm ready.
Great, because we are going to go live right now. And I'd like to welcome everyone who is here at Cloud Slam 09 for our event, Cloud Computing and On-Demand IT, enabling new levels of agility, flexibility, and scalability. And one of the things that cloud promises is scalability, of course, and cloud computing and virtualization do go hand in hand. We're going to talk about some new technologies, new methodologies of getting the scalability you need for your cloud computing application, whatever it may be. And we're very fortunate to have with us today Bob Quinn. Bob is the chairman, founder, and CTO of 3-Leaf Systems. He's going to talk about actually delivering on that promise of cloud computing during the next hour. But let me remind all of you that this is an interactive event, and we want you to participate, so submit your questions at any time using the question and answer tool located on your interface. We'll get to as many of those as we can during the end of our presentation. So without any further delay, let me introduce our featured speaker, Bob Quinn, chairman, founder, and CTO, that is, of 3-Leaf Systems. Go ahead, Bob.
Well, thank you, Michael. Let me start by saying when I started 3-Leaf and started researching the opportunity back in 2003, I had no idea that what we'd be working on would be applicable to cloud computing. I didn't know it back then. But let me run through my presentation, and as Michael said, pop in any questions along the way. So I'm using a different term here. Just let me justify it by saying I don't really know what cloud computing is. So I've gone back to utility computing, and let's see how well this would work in the cloud. So I'm showing here a 19-inch rack full of what I would call sweet spot commodity 1U servers. And today that's a 2-socket server with typically 8 cores total, or sometimes 12 cores depending on the processor family. And we can look at this rack and think of it in a couple of different ways. I mean, physically, it's clearly 32 servers, each, as we see here, with 8 cores and a bunch of memory. But another way we might like to look at it is why can't we think of it as 2 servers, each with 128 cores and a terabyte of memory? All the resources are there. It's only technology that's preventing us from doing that and thinking of it that way and using it that way. And similarly, 4 servers with 64 cores and so on and so on. And I think we kind of stop here at all of the above, but obviously you don't have to stop with 8 servers. You can go all the way to 256 servers, each with 1 core and a given amount of memory. So we view this as an ideal way of adjusting compute resources to meet the needs of the application, as opposed to attempting to find the right combination of applications that will fit on specific servers in order to, number one, of course, service their needs and provide all of the power and capacity that they want in that application, but also to drive up the server utilization so it's high and we're getting good efficiency in terms of dollars spent on power and cooling. So if we think about scaling on demand, I mean, loads can move around, and we tend to do that today. And of course, there are issues with that, right? Moving the loads around. If you're doing a lot of that, you're generating a hell of a lot of traffic. Loads are ping-ponging between servers, as you see on the screen. But I think the way